Hi everyone, actually I just finished my PhD a few weeks ago, and I just want to briefly discuss my research activity on the kinetic modeling of carbonaceous particle morphology. So basically, what are these carbonaceous nanoparticles? We discussed a lot about that this morning, but they are complex species formed from high temperature combustion or pyrolysis. They can have very different shape, spherical particles or aggregates with a fractal structure with the building block that is the primary particle. And we know that the morphology of these structures are extremely important for the surface activity of the species and their optical and electrical properties that can be attractive for practical application. Now, how can we model these complex formation processes and morphology behind the carbonaceous nanoparticle? We use the discrete sectional approach in which we consider beams as lumped single species. They can have a defined mass but different shape and nanostructure, where for instance liquid-like particles formed from gas phase precursor, the AGs, primary particles that has a more ordered structure, and fractal aggregates that are constituted by different size primary particles. So with this approach, for instance, if we take one of these beams, beam 12, with a fixed mass, we have different shapes. We have spherical liquid-like for primary particles, and then different aggregates that you can see below that can be formed either by a small number of large primary particles or by a huge number of small primary particles. So in this way, we can assign to all these beams the complex physical and chemical phenomena through reaction in the chemical format that allows the use of this model in most common numerical framework for flame and reactor simulation, and to validate the model against experimental data available in the literature for key morphological properties of carbonaceous nanoparticles. For instance, you can see on the right some comparison between the model, the lines, and the experiment, the symbols, for particle size distribution, PSD, or average permanent particle diameter in different flames configuration in different conditions, and you can see that the quantitative and qualitative agreement is quite satisfactory. Then for more details about the methodology adopted and the wider validation and also the limitation of the proposed model, I wait for you at my poster and the poster session tonight. And thank you for your attention.